Hey guys, Jake here coming at you with another live math lesson this week. Every Monday night, 5 o'clock Pacific time, 8 o'clock Eastern, come at you live and we go through some math problems, talk about some different topics, and give you a chance to answer any questions you have that you want to ask live. Happy Halloween. Today we're going to be talking about a couple different things. We're going to be talking a bit about linear functions. Specifically, we're going to be going over the point-slope form, how to find a function that fits specific points that you're given. We are also going to touch on how to transition from the point-slope form into the slope-intercept form, which is probably the more common kind of form that you see a linear function in. And then from there, we're going to get into step functions a bit, how to evaluate those and basically what those are, what those mean. So a couple good topics, good examples for you. We're kind of continuing on the track of talking about some precalculus topics here today. I've been kind of trying to cover those a bit more on my channel recently, so we can get more precalculus students and help make sure people who are here to learn about calculus have that solid background of the precalculus stuff that you need to know. So wanted to keep on doing that a bit today, and yeah, that's what we have in store for you today. So let's go ahead and jump on into the first topic and example here. So we're going to start with this one here. We're going to write a linear function f such that it has the indicated function values. Then we're going to sketch a graph of the function. So in this case, we are given these two sets of function values. We have f of 3 equals 9 and f of -1 equals -11. So really what this tells you, this kind of notation here, f of something equals something, that basically tells you that whenever you plug in whatever number is inside the parentheses here into your function f, you will get out whatever number is over here as an output. Really what that means is we have an ordered pair of a point that we know lies on our linear function. We know that it has to go through the point 3, 9 in order for this to be true. And then similarly over here, we know that if we plug in -1 into our function for x, we're going to get out -11 for y. So we know that it goes through the point 1, -11. So essentially what this problem is doing is it's giving us 2 points that we know our linear function has to have these 2 points on it. And we have to find the linear function that goes through those 2 points. So pretty much the process for solving this problem is going to be the same as the process for finding a linear function that fits onto 2 points. So to do this, probably the best approach that you could take is we're going to start with the point-slope form of a line. So the point-slope form of a line basically says that if we have y minus y1, that will equal m times x minus x1. Another way that you could rewrite this is simply by adding y1 over to both sides of the equation to basically move it over to the right side of your equation. So that's going to give you y equals m times x minus x1 plus y1. So this is the equation of a line that has a slope of m and goes through the point x1, y1. So this is just any point that we know lies on the line. So this can be any point that's on the line. So in this case, we know we have 2 points. So if we're trying to kind of figure out how to fit these 2 points into the point-slope form, we will be able to use either one of these points as the x1, y1 point in our line. It doesn't really matter which one you pick. I'll kind of get into that a bit more in a second. But we also need to find the slope of this line. We need to find the slope of a line that goes through these 2 points. So how do you find that? Well, kind of similar to how we can just apply this point-slope form of a line, there's pretty much just a formula we're going to be able to use for this. We know that the slope that goes through 2 points, the slope of a line that goes through 2 points, can just be written as y2 minus y1 over x2 minus x1. So this is basically just another way of saying rise over run. However many units you're going up from one point to the second, from the first point to the second point, divided by how many units you go over to the right from the second point to the first point. So it's just your units going in the y direction, which is up and down, divided by your units going in the x direction, which is side to side, so rise over run. So in this case, we have y2 is our second y coordinate, so that's negative 11, minus y1, which is our first y coordinate, which is 9, over x2, which is our second x coordinate, so negative 1, minus x1, which is our first x coordinate, which is 3. So our slope is going to be negative 11 minus 9, which is negative 20, over negative 1 minus 3 is negative 4. Negative 20 divided by negative 4 would be positive 5. So our slope is going to be 5. So we know that we're going to have a slope of 5. So our m is going to be 5. Then for x1, y1, we just need to pick either one of these 2 points that we know lies on our linear function that we're trying to create. So if this is making sense to you so far, do me a favor and drop a comment down below. Just say got it so far, so I know you're following along. So I know you've gotten up to this point. But from here, really, we can pick either of these 2 points. I'm just going to pick 3, 9. Like I said, it really doesn't matter. This is going to end up simplifying down to the same thing either way. I'm going to go with 3, 9 as x1, y1. So basically, 3 is going to be x1 in this case, and then 9 is going to be y1 in this case. So now we basically just need to plug in this point, 3, 9, into this equation right here, and then we just need to plug in 5 for m into this equation right here. So plugging those in is going to give us y equals m, which is 5, times x minus x1, which is 3, plus y1, which is 9. So now what we have is a linear function, which is in the point slope form. We basically took the slope of the line that we're trying to create, took a point that lies on the line, and plugged all that information into the point slope formula for the equation of a linear function. So what you usually want to do once you get a point slope form version of your linear function is to then basically just simplify it down into the slope intercept form. The reason why is because it's kind of just a simpler version of the same line, basically. So to do that, all you really have to do is distribute your slope in through the parentheses here. So 5 times x will be 5x. 5 times negative 3 will be minus 15. And then you're going to keep your plus 9 out here. And that's still going to be equal to y. And then from there, you can basically just combine your like terms. So 5x, there's no other x terms, so we're still just going to have 5x there. And then negative 15 plus 9 is going to leave us with minus 6. So y equals 5x minus 6 is going to be the final equation of this linear function that goes through those 2 points in the slope-intercept form. So I'm not seeing any questions in the live chat. As always with these live streams, if you do have any questions along the way, just throw them in the live chat. Happy to help address whatever questions you have. Even if they're off topic, I may be able to help answer some other questions that you have that aren't about the problem we're doing or even about the topic we're talking about. But just throw those in the live chat. If you are getting some value out of this video so far, do me a favor and hit that like button. We still got some more to go here, but if you're getting something so far, like definitely helps my channel, helps this video. Helps everybody. Help push this out to more people so we can get more people learning precalc. All right. Okay, yeah, so that's our first question. Let's go on to talk a bit about step functions. So let's do this problem here. We're going to evaluate the function for the indicated values. And I forgot to write the indicated values. Let me go grab that real quick. Sorry about that. So we're going to evaluate g of 1/8. G of 9, g of negative 4, and g of 3/2. All right, sorry about that. So we have a 4-part problem here. We're going to evaluate this function at these 4 different values. But before we get into how to do that, I want to take a second, take a kind of a step back and think about what this function is. G of x equals -7 times basically this step function component of this equation, where what's in the step function part is x plus 4 and then plus 6 after all that. So what does this mean, these little brackets here? This is what is called a step function when you have these brackets like this. Basically, the reason why it's called that is what it means is you're taking the lowest integer that is equal to or less than whatever is inside the brackets here. So another way to think of it, if you have ever taken any like computer science classes, this is kind of like taking the floor of whatever's in here. That's another kind of terminology that basically means the same thing. You're just taking the integer that is directly beneath whatever this is. So essentially think of it as rounding down to the nearest whole number. So whenever whatever is in here is a positive number, you're just rounding down. You're just dropping whatever's at the decimal or, other than the whole number integer that you have there. If this is a negative number, like let's say you're taking the step of -5.5, it's going to round down to -6. So the nearest integer that is less than or equal to -5.5 would be -6. If you have a positive number, though, it's basically just going to drop the decimal. So the step of +5.5 is going to be +5. So that's basically what this kind of double bracket means and what it does. So when we're evaluating these 4 different things, really just like any other function, when you're trying to take g of 1/8, for example, all that means is go to your function g of x right here. Wherever you see an x, just replace that x with whatever number is in the parentheses here. So we're just going to replace our x with 1/8 to find g of 1/8. So that would be -7 times the step of 1/8 plus 4, and then close that step function part and then add 6. So basically this is kind of the unsimplified version of what g of 1/8 means. You're just going to your function g, replacing any x you see with whatever numbers in the parentheses there, in this case 1/8. So let's go ahead and think about how to actually evaluate this now. 1/8 plus 4 would be 4 and 1/8. Since we're taking the step of 4 and 1/8, that's just going to be 4. We're just going to take the integer, the whole number that is directly beneath 4 and 1/8. So essentially it just kind of drops off that mixed number fraction part of it. So that would just be 4 times -7 plus 6. -7 times 4 would be -28 plus 6 would be -22. So g of 1/8 will be -22. Okay. So next we are going to evaluate g of 9. So again, we're just going to go to our function g. Wherever we see an x, we're going to replace it with 9. So doing that is going to give us -7 times the step of 9 plus 4 plus 6. 9 plus 4 is 13. And then taking the step of an integer whole number isn't really going to change it, right? Because the integer that is less than or equal to, and closest to whatever you're taking the step of, is just the integer, right? 13 is less than or equal to 13 and is an integer. So that's really all that's going to be. So that'll be 13 times -7 plus 6. -7 times 13 would be -91, I believe. 7 times 10 is 70. Plus 21 would be 91. Yeah, so -91 plus 6. -91 plus 6 would simplify to -85. So that's going to be g of 9. And then for g of -4, we're going to have -7. Again, we're just going into here, replacing the x with whatever's in the parentheses, times the step of -4 plus 4 plus 6. -4 plus 4 is 0. Since 0 is an integer, taking the step of 0 also does not change it. This step function is not going to have any impact whenever you have a whole number or an integer. An integer is just a whole number. Whenever you're taking the step of a whole number, it's not going to change it. So the step of 0 is 0. 7 times 0, or negative 7 times 0 is 0, plus 6 is 6. So that's going to be g of negative 4. And let's go on to g of 3/2 now. So that'll be, again, just going to here, replacing our x with whatever's in the parentheses here. We're going to get negative 7 times the step of 3/2 plus 4 plus 6. Okay, so now 3/2 plus 4, let's kind of just draw that off to the side here. 3/2 plus 4, whenever you're adding fractions, you always want to get a like denominator. So we want to get a like denominator of 2 here. So we would want to multiply 4 by 2 over 2, because multiplying something by the same number divided by the same number is just multiplying it by 1, which doesn't change its value. So 4 times 2 over 2 would be 8 over 2 plus 3 over 2. Now that they have the same denominator, we can just add their numerators. 3 plus 8 is 11 over 2. So we're going to have the step of 11 over 2 times negative 7 plus 6. 11 over 2 is the same as 5.5, so 5.5. I coincidentally kind of gave that as an example over here. Since taking the step of 5.5 is just rounding it down to the nearest whole number, the step of 11 over 2 is just 5. So we're going to have 5 times negative 7 plus 6. Negative 7 times 5 would be negative 35. Plus 6 is going to give us negative 29. So negative 29 will be g of 3/2. So still not seeing any questions in the live chat. If you did tripping over my words here. If you did get some value out of this video, out of these problems and topics, do me a favor and hit that like button down below. It's a huge help to my channel so I can keep making more videos like this. And while you're down there, hit that subscribe button and that bell icon. Turn on all notifications so you're notified when I'm going live each week. It's going to be 5 o'clock Pacific time, 8 o'clock Eastern every Monday night, where you can come get whatever questions you have about calculus, pre-calculus, really any math questions you have. Happy to help address whatever questions I can. You can come join live, drop your questions in the live chat. Happy to help however I can. So be sure to subscribe and hit that bell icon so you're notified when I go live each week. And we can keep crushing it in calculus all term together. Thanks, and see you next time.